This is the third lecture for Unit 4. This addresses the issue of concentration in stoichiometric calculations, in particular reactions in solution. Best way to begin is by thinking of an example. Suppose we have two different solutions and two different glasses, for example, and we mix them together in a bigger glass. One solution is aqueous lead acetate, and the other is aqueous sodium iodide. When we do this, a reaction occurs. Solid lead iodide forms, and the other product of reaction is sodium acetate, which is aqueous, remains in the solution. All right, let's suppose 300 milliliters of 0.167 molar sodium iodide solution is used for this reaction, and we'll assume excess lead acetate. How many grams of lead iodide produced? You can attempt this if you want before moving on to the solution. The key to this is that this is a stoichiometry problem like all others. The first step is to start with the substance you know about and find moles. The difference in this case is we are not concerned with grams. We're concerned with volume. Let me illustrate. We have 300 milliliters of the sodium iodide solution, which can be multiplied by a conversion factor to convert to 0.3 liters. These sorts of calculations are becoming more and more familiar to you. All right, I have just corrected a typo. Take the molarity, 0.167 moles of sodium iodide per liter, and multiply by the volume. This calculation, molarity times volume, gives us moles of sodium iodide. Now this, not grams to moles, is actually step one of the stoichiometric calculation. Notice no grams are involved. We found the moles by molarity times volume. Once you've done step one, you can multiply by another factor to go to step two. We have moles of sodium iodide multiplied by a conversion factor to convert the conversion factor, 1 mole of lead iodide over 2 moles of sodium iodide, the 1 and the 2 naturally from the balanced chemical equation as always. And then a final step, which looks like a final step or step 3 you performed by many times before. We convert moles of lead iodide to grams by multiplying by the molar mass in the numerator over 1 mole in the denominator. The solution is 11.5 grams of lead iodide. All right, again, the trick or hook of this problem is that step 1 does not involve converting from grams to moles, as you might have been accustomed to in Unit 3. Step 1 is finding moles of sodium iodide by multiplying molarity by liters. Given the same reaction as the first example, go back and look at the balanced equation if you need to. What volume of 0.46 molar lead acetate solution would be required to produce a kilogram of lead iodide? Here we'll assume an excess of sodium iodide. All right, again, this is a stoichiometric calculation. First step is to start with what you know about and convert to moles. What we know about here is that there's a kilogram of lead iodide. So step 1 will be convert a kilogram of lead iodide to grams and then moles. The next step will be convert the moles of lead iodide to moles of what I want to know about, which is lead acetate. In the third step, we'll determine the quantity of interest. Now note, In this case, the quantity of interest is volume, not grams. We're interested in the volume of a solution, and the volume is moles over molarity. Let me show you the calculation. Here is our mole highway solution. A kilogram is 1,000 grams. So we have 1,000 grams of lead iodide. That is converted to moles by multiplying by 1 mole over 46.10 grams. And we multiply by another factor, 1 mole of lead acetate over 1 mole of lead iodide. Use the balanced equation to convert from moles of lead iodide to moles of lead acetate. In the final step, instead of converting to grams, we take moles, which is what we calculate in steps 1 and 2, moles of lead acetate, and multiply that by 1 liter over 0.464 moles. Now essentially, what we have done is taken moles, steps 1 and 2 we find moles, and in the last step we divide by the molarity. Moles over molarity equals volume. Okay, now I've changed the word liter in step 3 to the big L to clearly show that moles of lead acetate cancel and we're left with liters. The solution is 4.67 liters. Alright, complete your notes on this before moving on. We'll try one more. 20.78 milliliters of 0.116 molar HCl solution is required to react completely with 21.34 milliliters of a sodium hydroxide solution. The reaction is NaOH plus HCl equals NaCl plus H2O. Notice that I corrected a typo there. Make a note of this problem. The question is, what is the molarity of a sodium hydroxide solution? Stop, complete your notes, and attempt the solution of this problem before moving on. Be careful to identify steps 1, 2, and 3. Alright, in step 1, you're going to convert what we know about to moles. And that will be done by multiplying the molarity of the HCl solution by the volume. That will give us moles of HCl. In step 2, we'll convert moles of HCl to moles of what we want to know about, which is sodium hydroxide. In step 3, we want to determine the quantity of interest, which in this case is molarity, and molarity is moles per liters. Right. Note that all volume units should be in liters for this problem. Once you've identified the steps, you put them together. Step 1 is molarity of HCl times the volume. Note I've converted the volume to liters. Step 2, 1 mole of sodium hydroxide over 1 mole of HCl converts from moles of HCl to moles of NaOH. Step 1 and Step 2 give us moles. Step 3, 1 over 0.02134 liters, is essentially dividing moles by volume to get the molarity. Notice that I had to convert from milliliters to liters. Alright, so the solution is 0.113 moles of sodium hydroxide per liter, or 0.113 moles per liter. Right. Note that we did not use any molar masses to solve this problem. Because at no point were we asked about or provided any information about masses. Alright, this concludes the final lecture for Unit 3. Rather, for Unit 4.